In the very first video of chapter 3, I showed this example when talking about oscillating motion in general. What if what I want to model is some type of undulating wave pattern? So by the end of this particular video, I want to have something just like this example for you to be able to work with. And where I'm going to start from, however, is this example, the one that I ended with in the last video, that is one single dot or circle oscillating up and down the vertical axis of a P5 canvas. So how am I going to do that? Well, if I wanted to graph a static wave, what I would do is I would consider in a P5 canvas every x pixel to be an angle value. And then I would calculate the sine of that angle and map that to some y value. And I could say begin shape, end shape, vertex, 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 and connect them all. I have an example that I'll link to in the video description that does exactly that. But I'm going to do this in a slightly different way. Ultimately, it's the same thing in the end, but I want to start with it in motion. I want to think about this one dot as an object oscillating up and down. And then I want to make an array of those dots. And I want them all to oscillate up and down. Now, there's a lot of things you could do here just by starting to vary the period and frequency of each one of these dots moving up and down. I almost want to just do that right now. Let's go ahead. I'm gonna do that right now. I'm going to start by taking the single angle variable and make it an array called angles. Then it will be useful for me to keep track of the size. I'll just use a variable for the radius of each one of those circles. And then I need to know how many circles fit across the entire width. And that should be an integer value, so I will just take off the decimal place. Then I can write a loop to create all the elements of the array, all the angles for every spot. Now, instead of just drawing one circle here at x equals 0, I want to draw many of them, a circle for every single spot in that array of angles. Let me comment out the incrementing the angle for a moment right now. And I need to figure out where is the x position of every circle. To do this, I'll use the map function again. And remember, I have translated to the center here. So I want all of the circles to be between -300 and 300 because the canvas is 600 pixels wide. Oh, and this, of course, now, very, very important. It's not sine of the angle anymore. It's sine of angles index I. And now you can see I have now drawn many circles across the horizontal axis. If I were to bring back incrementing the angle, do it inside the loop, angles index I plus equal angle V, and the line should also correspond to x. We can now see I have all of the circles oscillating up and down. They're all oscillating at exactly the same period with exactly the same amplitude. As an exercise, you might start to think about, oh, how could I vary the amplitude of each of these? Or how could I vary the period? Well, let's vary the period or the frequency just by having an array of these angle V values. So now all of them have a completely random value. So they're all offset kind of just with no logic to them whatsoever. I could do something like say oh, let me say I divided by 10. Oh, that's too much. I divided by 100. Now you can see their periods have a relative relationship to each other. They're faster on the right side, slower on the left. So they'll get out of, they'll sort of end up in these with these different patterns. You can see the one on the left is always just never changing because I started at 0. So it probably would make sense for me to say, oh, this is 0.01 plus I divided by 100. So that one would at the very least move. So again, I've kind of done something different than what I actually intended to do when I started making this video tutorial. And you could probably pause here and start to play with this idea and think about different ways that you might visualize this. But I want to get back to talking about the reason why I was here in the first place, which is phase. I want to see this graphed like a sine wave. The way to do that is simply have a different starting angle for each one of these dots. For example, if this dot starts at angle 0, then its sine of 0 is in the 0 position. Then this one might be slightly higher at angle 0.05, 0.1, 0.2. We'll start to see that graph play out. Maybe I want to see the full sine wave and make sure the starting angle here is 0 and the starting angle for this one is 2 pi. Let's see what happens when I do that. First thing first, let me take this out so that now we're back to having just the circles flat along the horizontal axis. I want to give them a different starting angle. Where is that starting angle? What is that phase? All of the starting angles are 0. So I could say map I, which goes from 0 to total, to between 0 and 2 pi. And now you can see there is the graph of this sine function. One full cycle through the wave from 0. And it kind of, for some reason, the way that I've drawn this, I'm missing the last one. So I might do something like add one extra one here. And we can see I have that last one filled in on the edge of the screen now. Let me change the way I'm rendering this to be a bit more clear. I'm going to remove the line, and I'm going to make R quite a bit smaller. And we can see there are all the dots now graphing that particular sine wave. If I wanted a higher frequency wave, if I wanted to see all the sine wave cycle through twice, I could say, let's look at all the angles from left to right between 0 and 4 pi, or 2 times 2 pi. And now we can see there's 2 cycles through the wave. Now, do I want this to be more like a graph? Right? There's a lot of space between these dots. So here's where I could come down here and change the way I'm rendering it. And I could say begin shape, end shape, and vertex at x, comma, y. Oh, interestingly enough, it's got a fill to it, so it's actually trying to make it a shape where it actually fills things in. I'm going to just take that out for right now. I could also comment out the circle, and there we go. Now, what happens if I go back to this idea of angular velocity? What happens if I just add that back in? Whoa, so it's doing some crazy stuff because, again, I've got this weird, crazy pattern of all of the dots also having a different period in frequency. So I love this sort of like strange, unexpected artifact I got here. Apologies for the sort of flashing. Now I can go back and add in the idea of incrementing each angle for each position as well. Now, I encourage you to try variable increment values like I had before. You'll get sorts of also strange artifacts and patterns. But I'm going to simplify things and just have them move together, which ultimately ends up giving the quality that makes it look like I am panning across the wave. Essentially, I'm sliding the wave across, which is ultimately what I'm doing. They're each starting at a different angle. Then each angle changes. It's like shifting the thing. If I go back to rendering these as circles, we can see once again, it looks as if these circles are moving along this path, but really each one is just moving up and down at exactly the same oscillation with a slight phase offset from the one next to it. So what might you do with this? Hopefully this is sparking some ideas in your head about what kinds of visual patterns you might try with different shapes and colors and periods and ways of visualizing the wave patterns. Certainly, could you create this wave pattern around the perimeter of the circle? In the way that I showed you how to use polar coordinates to draw your own circular shape, could you offset the various points, vertices of that circle according to a sine wave? The other thing, which is less of a creative output idea, is that this isn't going to be super easy for me to work with going forward. I might want to do something where I consider each one of these dots an object. So maybe it stores position and angle increment. I'm not sure, but to sort of package all of the idea of one of these moving up and down into an object, that's something that you might try to do. Or perhaps the wave itself. What is the starting angle? What is the ending angle? What is the phase offset? What is the period? What is the amplitude? Whatever the properties are of a wave itself, could you make a wave class? And then you could make a bunch of different waves simultaneously in the canvas just by making them as objects. So I'll try to create some example solutions to those exercise ideas. You'll find those linked in the video's description. But in the next video, what I actually want to demonstrate is how to take this idea and turn it into something like this. What this is not just the result of graphing one wave, but it's taking multiple sine waves, possibly cosine waves, with different periods and different amplitudes and adding them together, summing them to get one resulting wave, an additive wave. So that'll be the topic of the next video. I'll take this example that we just did and look at how to add multiple waves together to make a more dynamic pattern. As always, if you've made something from this video, check the link in the video's description where you can share the results of what you made on the Coding Train website, okay? See you in the next video, I hope. Goodbye!